Andre says, I know that I can find the distance between 2 points in the plane by drawing in a right triangle and using the Pythagorean theorem. But I'm not sure how to find the lengths of the legs of the triangle when I can't just count the squares on the graph. Well, maybe you can relate with Andre. It's easy when you just can count the squares on the graph, but if the squares are kind of a lot and cannot be counted and the scale kind of skips, it's pretty much difficult to figure out horizontal distances and vertical distances. Now, how would you explain to Andre how he can find the lengths of the legs in the triangle in the image, then calculate the distance between P and Q? The main focus of this lesson is finding the distance between 2 points as well as finding the midpoints. Let's help Andre. First of all, Andre is on the right track, drawing a right triangle in order to find the distance between point P and Q, which is the length of line segment PQ. Analyzing Andre's drawing, we can actually determine the coordinates of n. It's easy to determine. Well, n is vertical in a vertical line with point Q, so n must have the same x coordinate as point Q, so it's going to be 53. Now, n is also in the same horizontal line as point P, so n must have the same y coordinate with point P, so it's going to be 12 right there. So now that should help Andre find the length of the sides of the right triangle that he just drew. Okay, this side right here, this side is just gonna be the difference between the x coordinates. Okay, we can say that that's equal to, I'm going to use a different color. Okay, 53 minus 8. Okay, 53 minus 8. And because we're dealing with distances, we're going to find the absolute value. Okay, the absolute value of 53 minus 8, so that it doesn't matter which order you subtract. If you subtract 53 minus 8, it's going to be 45. If you subtract 8 minus 53, that's going to be negative 45. You take the absolute value, it's still going to be 45. So this length is 45. And how did you get that? Well, you subtracted the x coordinates. Keep that in mind. Now, to find the horizontal, the vertical, okay, the vertical distance, this distance right there, okay, all he has to do is subtract 22 minus 12. And again, since we're dealing with distances, we just take the absolute value. So 22 minus 12 is 10. The absolute value of 10 is 10. So this is going to be 10. Now, since 45 and 10 are legs of a right triangle, we can now find the distance between P and Q, which is the length of line segment PQ, which is the hypotenuse of the triangle that Andre just drew. So let's help Andre find the distance between P and Q. So you can say that it is, well, PQ squared, using Pythagorean theorem, PQ squared is equal to 10 squared plus 45 squared, or 45 squared plus 10 squared. And it's going to be, taking the square root, is going to be PQ is equal to the square root of 10 squared plus 45 squared. Simplifying that is going to be the square root of 100 plus 45 squared is 2025. That's going to be equal to 2125. 2125. The square root of 2125 is equal to 46 point, around 46, approximately 46.1. 46.1. So keep in mind here that finding the distance between 2 points, in this case points P and Q, is a little bit is way similar to using the Pythagorean theorem. Andre also needed to find the midpoint M of line segment PQ, meaning to find the coordinates of the midpoint M of line segment PQ. How would you explain to Andre how to find the coordinates of point M? So we know that the midpoint divides the triangle into two, and then the triangle divides the line segment into two congruent segments. So you can approximately find the midpoint somewhere like there. Okay, that's gonna be point M. But what we are interested in are the coordinates of point M, meaning what's the x and the y coordinates. Now we already know that the coordinates of N are 53, 8, 12. I mean 53, 12. Now to find the midpoint, the coordinates of the midpoint M, okay, we need to understand that, well, if M is the midpoint of PQ, it's also the we can extend it so that we have, that's also a midpoint, and that's also a midpoint respectively of the legs. All right. So the x coordinate of M is the same as the x coordinate of the horizontal leg, and the y coordinate of point M is the same as the y coordinate of the midpoint of the vertical leg. The way to find the midpoint, well, the x and y coordinates of the midpoint is to add the x coordinates. So it's going to be 8 plus 53. That's going to be, okay, 8 plus 53 divided by 2. Or just take the average of the x coordinates. Doing that, you're going to get 61 over 2. That's 61 over 2. Also, the y coordinate, you can just take the average of the y coordinate. It's going to be 22 plus 12 divided by 2, which is equal to, well, 22 plus 12 is 34 divided by 2 is 17. Okay, so now that's 22 plus 12 divided by 2. So the coordinates of the midpoint are, okay, x coordinate is 61 over 2, or 30.5, comma, the y coordinate is 17. So the coordinates of the midpoint M is 30.5, comma, 17. All right, so that's how you find the midpoint of a line segment if you know the coordinates. Now, let us summarize all of this. In a coordinate plane, or the x, y plane, if we have 2 points, let's say we have 2 points A and B. And we know the coordinates of point A. Let's say the coordinates of point A is x1, comma, y1. And the coordinates of point B as x2, comma, y2. You may notice that the labeling of the coordinates is the same as when we are finding the slope. All right. The distance formula actually tells us that distance AB, or the distance from point A to B, or just sometimes D, in this case you just write AB, is equal to the square root of x2 minus x1. It's going to be, well, we take the absolute value, okay, to be more precise. This is going to be the absolute value of x2 minus x1 plus the absolute value of square plus the absolute value of y2 minus y1 squared. Okay, that's the Pythagorean theorem part of finding the distance between 2 points. Now, the midpoint M, okay, let me see here, will have the coordinates, okay, the midpoint M will have the coordinate, just add x1 plus x2, or x sub 1 plus x sub 2 over 2, the average of the x coordinates, comma, and the y coordinate is going to be y sub 1 plus y sub 2 over 2. So take note of these two formulas. Okay. Now, in some other books, the distance formula will take the form. Sometimes you will see that the distance formula is just AB is equal to the square root of, instead of the absolute value, you will see parentheses. It's going to be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay. Now, does it matter? No, it doesn't matter because you're squaring it. Okay. But we're using the absolute value just to emphasize that we are actually dealing with distance between two locations, and distances are always positive. All right. Let us apply these two formulas. Find AB, or the distance between point A and point B, or the length of line segments AB. The first step would be to label the coordinates. It's going to be x1, y1, x2, y2. It doesn't matter which one you label x1, y1. Okay? What matters is x1 must go together with y1 and x2 must go together with y2. All right. So now let's find the distance. It's going to be AB is equal to the square root of, well, the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 squared. All right, let's do that. It's going to be AB is equal to, let's plug in what we know. It's going to be absolute value of 3 minus, as x2 is 3, minus negative 2 squared plus the absolute value of, well, y2 is negative 2 minus 4 squared. Let's simplify inside the radical. It's going to be, well, 3 minus negative 2 is the absolute value of 5 squared plus negative 2 minus 4 is the absolute value of negative 6 squared. That's equal to, well, absolute value of 5 is 5 squared. That's going to be 25. Plus absolute value of negative 6 is 6 squared. That's going to be 36. So you'll have the square root of 61, which is approximately 7.8, 7.81 or 7.8. 7.8. So AB is equal to 7.8. All right? Find the midpoint of AB. What's the midpoint of AB? Well, the midpoint has the coordinates, well, x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, that's our formula. So now let's just substitute. Okay, what we know. x1 is negative 2 plus 3 over 2, comma, it's going to be y1 is 4 plus negative 2 over 2. Okay, so you'll have the coordinates of the midpoint are, it's going to be, well, negative 2 plus 3 is 1 over 2 is 1/2. 4 plus negative 2 is 2. That's positive 2. Divided by 2 is 1. So the midpoint is 1/2, comma, 1. Replay this video as many times as you need to, and then complete the exercises so that you can apply what you have just learned.